Hello everyone and welcome to this new video tutorial. We're going to see right now background subtraction. Let's see an example. So we have this video. Let's suppose that our background is the landscape with the road and our foreground are the cars that are moving. So with background subtraction, here we want to detect, for example, the empty road without cars, and when cars are passing, we can subtract the background with empty road and the image with the cars, and so we can detect that the cars are passing. So this function is good method for us to track object movement. There is one condition, that the camera must be stable, so the background must be always the same. Let's go into practice. Import CV2, import numpy as np, then we load the video that I just showed you. Cap is equal to cv2.video capture, and the title is iway.mp4, and you can download this video from the link in the description. While true underscore and frame is equal to to cap.read, we show the frames, so c2.im show frame and frame. Key event, so key is equals to cv2.wait key 25. If the key is equals to 27, we're going to break the loop. We release the camera, actually not the camera, the video in this case. Cap.release and cv2.destroy all windows. So actually when we have a video, I don't think it will make any difference. This is mostly to release the camera. Anyway, let's see if everything is correct and if we can see the video, and probably too fast. Yeah, too fast definitely. Let's make a little bit longer waiting between the frames, so 33 milliseconds, and now it's more or less normal. Probably the right one is 30 milliseconds. Anyway, so let's now do something really simple. Let's subtract from the first frame. We subtract each frame on the loop. So first we get a frame, so first frame is equals to cap.read, and let's even show it. c2.im show first frame and first frame. So we have this first frame, which is always the same. From this one we are subtracting this one. So we can say difference is equals to cv2.appsdiff. We take first frame and frame. Let's show the difference. So cv2.im show difference and difference. And you can see that we already got some interesting result. There is some problem that in the first frame the background wasn't that clear because we had already some cars, but where there were no cars we can see some good results because we can detect the movement of the cars. So we can do something else. Right now we can, for example, improve this working with gray frames and taking only a threshold. So we don't want to see the car in details, but we want to see a white part where the cars are moving. So we can, let's say, do something like this. First frame we convert it to gray frame, so first gray is equals to cv2.cvt color first frame, and we convert it to gray, so cv2.color underscore bgr to gray. The same for each frame, so gray frame is equals to cv2.cvt color frame, and again cv2.color underscore bgr to gray. So we're going to calculate the difference of the first gray and of gray frame. So let's see now the difference. Okay, what we want to do right now we want to detect the car only as a white parts without detecting all the details. So for example, here we can see that there is something in the background that are not completely white but are a bit gray, and here the cars are more white than this background. So we can give a threshold. We can say if the pixels is above this value, so if it's more white than this, we are going to show it, otherwise we are not going to show it. So the difference will be difference is equals to cv2.threshold, the threshold of the difference, so this one it's here, the threshold. So we know that the values go from 0 to 255, where 0 is black and 255 is completely white. So in the middle we want to say if the pixels is more whiter than like 25, then let's make it white, and we're going to apply the threshold algorithm thresh binary. And here there is something to correct, red and difference, because the threshold returns us two results. This one is the actual threshold, this one it's just true or false. So we don't even need this one, we can just put underscore, we need only difference. And let's see the result. And you can see that we got a pretty decent result. Can we improve this? Of course. We can do some improvement. For example, we can remove the noise of the image. We can apply some Gaussian blur to remove all this noise, because of course pixels are not perfect. When you compare first frame to each frame, even if it looks equals, there might be some lighting change. Or here you can see that the tree is moving and the wind probably is making movement or all other things. And so Gaussian blur will improve this. So gray frame is equals to cv2.Gaussian blur of the gray frame. We are going to put a kernel size of 5 by 5, and there is sigma value which 0. And let's see if we got some improvement. Actually probably made it worse. Oh yeah, because the Gaussian blur must be applied also to the first frame. So first gray again, the same Gaussian blur of first gray. Okay, and you can see a huge improvement. We can of course still improve it. For example, we can apply some morphological transformation and delete or these white points. But we're not going to do that right now, because we're going to see a more advanced function to do background subtraction. So what's the problem? The problem is that we don't have a right background, as there are the cars on the first frame, so we will need to wait when there are no cars at all and take that frame, which is possible, but it's not a good practice. And also, for example, if we take the first frame at daytime, when it's going to be night, also all the background is going to change, so the script is not going to be stable and we're going to get many false results. So we need some better function that adapts in real time. And now we got an error because the video finished, and so he doesn't have anything to show anymore. So this is this is a manual way of doing background subtraction. I'm going to save this code and put it for you if you want to take it. You can check the link in the description. And now we're going to create another code using an OpenCV function just to do that. So again, here I'm going to type the missing things. So cv2.im show frame and frame, and now let's load the background subtractor function. We have let's call it subtractor equals to subtractor equals to cv2.create background subtractor mog2. What does this function? So this function adapts itself to subtract the background with the last 120 frames. So if during the video there is some lighting change or some other changes, the subtractor is going to adapt itself. Also, this function incorporates already itself the Gaussian filtering and some other filters like morphological transformation to remove the noise, and also a function that can detect the shadows. So for example, here we have the car moving, but also there are shadows, so this function also works to detect shadows. So let's use it and see how it works. So we have subtractor equals to, let's call it mask. It's equals to subtractor dot apply, and we're going to do that on the frame. And let's show the frame, and let's show also the mask. cv2.im show mask and mask. It's not perfect, there is a bit of noise. We can of course do some improvement. For example, we can say, let's see what this does offer to us, the history, so we can change the number of frames to work with. So as I said, it starts working with the first 120 frames and then it's going to adapt itself. We can say to adapt with only the last 20 frames, so it will be much faster adaptation. We can change, for example, the threshold let's say 25. Also we can say detect shadow, it's by default true, we can say false or true, it depends on what we need. False and true. So this is up to you to adapt this function. So what can we do after we have this? After we have this, we can detect the movement of the cars. So here we have the cars, we could draw contours on these cars. So if this white part is bigger than some certain size, we can say, okay, this is a car, we can draw contours, so it will be like a green rectangle showing the movement of the car. And for example, if you want to count how many cars are moving this way, how many cars are moving in the other way. We have other functions for background subtraction. We are not going to see them in this video, but keep in mind that this is not the only option that you have. This is all for this video. Hope it's clear for you, and thanks for watching.